Hi everyone, welcome to class, final class of CS202. I just had my last 302 class and now we have our last 202 class, right? So let's get it over with so that you all can study for the test, right? So today we just have a review day, just the same thing as 302. And so, my dog here. I am just opening the floor to questions for anything related to the course, final, etc. I'm going to just open up on Canvas really fast. See what the deal is with the final. Thank you, appreciate it. Although I'm not a fan of how the front came out. It's a little too long here, or at least I have to gel it or something. But yeah. Tonight, so if you want to turn in your notes for them to be possibly included in the extra credit, then email them by tonight, by midnight, basically. Let's see, where is it? I'm looking for the final exam. Quizzes. I heard like music playing. CS202 Fall 2021. This is midterm. Final. Here we go. So it's you know, I put it as a hard deadline for the completion of the final to be on December 1st for the 202 cohort. So it could change in the next 2 days, but I think it's just, you know, they're still just kind of going over the questions to make sure that everything is clean and things like that. But I think the structure is done. I don't think that's going to change. So to me, it looks like you have about 33 questions to do. Remember, there's like a final question at the end that allows you to upload files if you want, and there's the first question. So I think 33 questions. 32 actually. 33 or 32, no. It's a mixture of, it's a comprehensive exam, it seems. But the majority of the test will focus on what should be the latter part of the course, really, like linked lists and whatnot. But yeah, it's comprehensive from what I see here. So, for example, I'm not going to tell you what the questions are, but damn, this is hardcore. Whoa, that's a pretty hardcore question. I have to ask them to get rid of that. This is like, it's using like math symbols. Like, let me do a variation of the question. Here's the 3i. The question is like, yo, make a recursive function that does this computation. And so it's not like hard if you know how to translate this into like coding. But if you don't, then you're gonna be like, what? So this is actually a good one to review. So the question is like different numbers, same concept. And so first of all, the hard part here is understanding the math terminology. So this is summation. I'm sorry, I put n here, it should be 1 or 0, doesn't matter. Let's just do 1. So what this is saying is do a summation of all the terms, 3i, going from I equal to 1 all the way to whatever n is. So this is a glorified for loop. Okay. Now this is asking for recursive, but let's do the for loop version first. So when you do a range based, or not just a for loop actually, if you say int I, which is the same I as here, and you initialize it to whatever this is initializing it to, so like a 1, and then you say I is less than n, which is what you want to terminate with whenever it reaches n. And then in here is where you're increasing I by every single time, which it should just be I++ usually. Okay? You email them to me. Email me your notes. Oh, by the way, reminder, today's the final date for extra credit redemptions. So you go ahead and redeem them, and same deal, message me and everything. I did make a smaller tier, 50 point for you. So for you everybody here. But because I know that was brought up, so get that the Cyber Monday points deal or whatever. Okay, so yeah. All right. So anyways, going back to this. So that's really all it is, and then you just gotta store the computation somewhere. So like, let's say you move this somewhere else. Let's put a little sum equals 0 here, and all you gotta do in here is put whatever you have here. So use a different color, so because I'm gonna overlap things. So that goes here as a plus equals. Like that. Okay? Now they're identical. So when you see this, this is fancy talk for a simple for loop. Just another example. What would that be? That would be for int I equal to 0, I is less than 20. Is that inclusive? Shoot, is it inclusive or not? I don't think it's inclusive in summation. No, it might be. Let me check. Quick Google. Is summation inclusive? Yeah. Apparently it is. Fun fact: the little e is called sigma. I forgot actually that until I saw that. Tell you that. So big sig. Wait, big sig? No, big pi. That's a different thing. Okay, yeah. I was like, what? I remember that being a thing. Okay. Yeah. So it's inclusive. So because it's inclusive, technically speaking, I guess that should be I is less than or equal to, right? Because you want to include the n summation, I suppose. So that would be okay. And same here. I would be I is less than or equal to 20. And then whatever you have in here is what you put in here. But make sure you do a sum. Okay? So yeah. Sigma e. Okay, so yeah, so now that's the iterative version, right? So this is asking for recursive version. So let's do the recursive version of like that, okay? And then we can do this one too, but it's the same thing. It's just that one's more of a general case. So recursive of this, let's just call it function. This it doesn't actually give it a function, so or give it a function name specifically. So just do foo or whatever. Don't pick a long function name so that you don't waste time on those kind of things. So really, you just gotta keep track of things like the sum. Actually, you don't see. There's multiple ways of doing this. You could keep track of the sum as a parameter, or you could just make it return that. So I'm gonna do the return version because it saves me one variable. I'm actually gonna go with a double, just because this doesn't say how big the number can get. So, play it safe. Double can keep bigger numbers, so why not? And then really what you want to pass in as the parameter here is when to stop and where you're at. So we're going to call where we're at our I that we have. So you know, we'll just say it's an int I, because that one's a counter, so integer is fine. And then we want to know when to stop, so that is going to be our n, right? And as long as you keep track of that, then I think you're good to go. You don't need to keep track of anything else. And so remember, the three things you want in recursion are your base case, your recursive case, and doing something to get you to the objective of what you're doing the recursion for, right? And that can all be kind of combined into one line of code even sometimes, but you know, especially for a task, no one's gonna care if you don't do it elegantly. You want to do it the safe way. So I like to do the safe way too. So I'm gonna make my recursive case be very separate. Just make sure there's no confusion. And that recursive case is whenever I is greater than n. I'm not saying equal to n because again, we want to include that one extra count, I suppose. So I'm going to say, in that case, let's just return 0. We're not going to add anything to that running sum. Okay, otherwise, then we're going to take the current value of what we want to do, which is 3i, right? 3i. And we're going to add that to whatever the remainder is, which is going to be foo I plus 1 and the same n. So we can just pass n. And all of that, I could put this into the same line as the return line, but again, I'm trying to play it very safe and keep things separate. So I'm going to say sum is equal to that, and then I'm going to say return sum. Okay? And that will get you there as long as the initial function call is done like this. Foo 0, comma, and then whatever n is. As long as that's the case, then this will work. And I will also put this in your, so if in like this kind of question, if you get it, like what the initial call is, just so there's no confusion of that. So like call like this, just write a comment saying that. And then it should work. Yeah, because when it gets to 20, it's going to return 0, so I'm not going to add anything. Now, could this be made a little bit cleaner? Yes, you can do it whatever you want. I'll just give you one other version of this, which looks cleaner to me, but it's just as valid as the one I just showed you. That could be good. You could also put it as an else instead. But yeah, that would be a shorter version of that. Shorter, like really just combining stuff. But this is a little bit harder to understand the base case, okay? But they're both the same thing. This is an I, by the way. Okay? So, yeah, good recursion review, just in case you needed it. And also because that question looks scary. Let's see what else is interesting here. And like I said, if you have any questions or if anything you want me to go over, yeah, just post it. You said you were allowed to double redeem the attendance points, right? Yes, you are allowed to do that. But today's the last day to redeem, so make sure that you redeem things. So, yeah. Given a template list class is blah, blah, blah. I almost read a question out loud by accident. So yes, you're given a template class, and then you have to analyze what a variable is and whether it'll work or not. Whether it will work or not. So I guess it's a good thing to make sure you have an IDE working locally, preferably, so that you can check your code, not just whether this runs or not, but like I mean. Sure, you can just run it and see if it compiles and runs, but it's asking you to explain if something is wrong. So more than likely, you would have to explain it better than copying and pasting the error message. But also when you're writing your code, like for example, you're writing this foo function and you want to test it, it would actually be useful to to be able to check the code and see if what you're submitting works, right? If you have the luxury of the time for it. Okay, this one's linked list related, simple. Some stuff about nodes and linked lists, yeah, okay. Some stack questions, some queue questions. So yeah, it does seem like the majority of the questions are going to be focused on the linked list, stacks, and queues topic, but it is comprehensive, and I do see some questions on other topics as well. In fact, I think there's a way. If I go to, yeah, so okay. This tells me the topic of the question. So I'm going to tell you some of the topics of the questions, right? So for example, we have question pools for each topic. And so what it does is like, for example, we might have a question on templates, right? So like we built like 20 template questions, and then it will randomly pick one of those and put it in your test. So your test is different than your neighbor's test and so on. And so it's good because it allows me to know which topics are going to be there, because we labeled the question banks by topic. So, you know, we have 4 questions that are going to be from a medley from exams 1 and 2. I guess maybe that means from old tests. You might get like 4 questions that come up from those topics. And then you'll have 2 short answers from old tests as well. And then there's 1 question on classes, 1 question on inheritance, another question on inheritance, but it's under a different category. So maybe like one of them is on programming inheritance, the other one's on like understanding inheritance, maybe, I don't know, whatever it can be. Then you have 2 questions on pointers, 2 on exceptions, 2 on operator overloading, 2 on recursion, 2 on templates, 1 on virtuals, and then like 5 or 4 on linked lists, and then another 4 or 5 on stacks. And then you got a programming one, which I assume is like a bigger programming question. So let me look at those and see how big we're talking. So this can be anything, really, from what I'm seeing. But more than likely, it'll be related to linked list. So one of them is asking sorting. If you do sorting, just do bubble sort. But yeah, the programming one's like, it's kind of RNG if you get one linked list related or stacks and queues related or whatnot, even operator overloading. But I would leave that one to the end and do the shorter ones first, so you can maximize your points per minute that you can do. That's a really fancy thing. It's like almost flying off the screen. So, but yeah, that's all that I can think of. So really what I want from you all is questions that you want me to go over, like topics or anything of the sort. So is there anything you want me to review or refresh? Is your chance. Like I said, today it's on you. I have nothing really. I mean, I can talk about Python, but I would much rather go over stuff. Like just kind of how I did the recursion. Maybe there's a specific question that you have or something. So yeah, just anytime, just post them on chat. In the meantime, just because I had, the thing about templates, let's just really quickly review the syntax for templates. There you go, there's your template. So I can do like foo. I think print data. And some obscure function called print, or we could do cout data. But make sure it's overloaded. Or that you're using a built-in data type there, otherwise that wouldn't work, right? That's the big thing with templates, right? This will compile, but the moment that you try to feed it a function call and it resolves that to, like, let's say a string, you know, it's going to try to see if cout a string would work, which it will. But if it's an object that you don't have a cout statement overload, you know, the always stream overloaded for, then it will not compile. Maybe example questions about linked list stacks and queues. Okay, I can try those. Let me see. I'm going to look at the ones that are on the test so that I can get an idea of the fields of the question. So you said linked list, stacks and queues. So let's try a short answer linked list and maybe a stacks and queues short answer. Because the multiple choice ones, you know, it's like kind of, there's not much there to do. All right, so I guess let's talk about, you know, they might ask you things like comparing arrays and linked lists, you know, that sort of overview, right? Like when you use one, when you use the other one. And we did kind of talk about that when we were talking about stacks and queues and how you have to resize an array, but you don't have to do that with a linked list, right? So let's think about that for a second. The linked list has two major components to it. Well, the node has two major components to it. It has a pointer or multiple pointers, and it has a data component, right? Why do I say multiples? Because if you have something like this, when you have your data on a single pointer, it's a singly linked list. You also have a double or doubly linked list, and that's the one where like your data is there, and then you have some sort of next pointer, but you also have a previous pointer. And you sort of double link the list. That's why it's called doubly linked list, right? And so the cool thing about a linked list is that you can just keep building nodes and appending them to the list, inserting them, and not have to worry about resizing something. Whereas with an array, when you're allocating an array in memory, it's a contiguous block of memory. And so there may be other memory on top or on the bottom of that. So it's not as easy to like resize an array where you can just grow it. It's going to be all over the place. And so you have to basically build a new array that's bigger, copy the data over, and that's a slow process. And so linked lists have an edge on that. They are able to very quickly insert and remove data. The disadvantage comes with access time. With an array, you can access any part of the array at any time immediately because it's just an address, and you know exactly how to get that address. You know, like if an array lives at memory address 0x113114f2 or something, and then I say I want to get the next spot of this array, you automatically know that it's just going to be a shift. In this case, let's say the array is of integers, so it's a shift of 4 bytes. So you use do plus 4, and so this 2 becomes a 6, right? You can do the same thing if you wanted to get like the 40th item of the list, or the 10th item of the list would be just plus 40, right? So you could do that very easily, no problem, immediately. With a linked list, you can't do that. With a linked list, if you're trying to access like the 10th element of the list, there isn't a way to just like immediately go to the spot. With the linked list, you have to basically traverse the list by going through all the pointers with a little while loop, and just basically hopping around, counting how many hops you have. And once you kind of get to the spot you want with like the 10th item, so the 10th hop, then you're able to retrieve the data. Not as fast. And so it's a little bit of an introduction into algorithm analysis in 302 that the memory organization of a linked list has the advantage of creating and removing nodes without problem very quickly, but accessing time slows down when you're trying to access random spots in it. First and last item, not a problem. Spots in the middle, not so good. Could you speed that up? Could you make a pointer like right in the middle? Yeah, sure, you could cut the time in half, but again, like now you have an extra pointer, And if you're trying to access something that's 3/4 of the way in, that's going to be slow. So you're like, well, let me add pointers there. Soon enough, you have a pointer for every single spot, and you might as well would have made an array at that point. So that's kind of like the summary of why linked lists are cool for some things, but not cool for some other ones. Okay. Other examples of questions that I can kind of modify from this. Pointers. So when would you have a pointer as, when will your node be made up of just pointers? Think about that for a second. Okay, this is like a short answer kind of question you get. This is not asking you to code anything. It's asking a concept, but you know the concept, but it takes a little bit of time to think about. So you're like, right now, what I just showed you is you have pointers, but you also have actual data. Could you ever have a linked list where you have just pointers? Well, let me simmer that for a little bit, not to give you the answer right away. Could this node be made up of just pointers? If you have the answer, you can blur out in chat. So we'll come back to that in a little bit. I'll let it simmer, like I said. Okay. Looking at stacks and queues, the most obvious things people will ask you in the test are going to be pros and cons of stacks over queues. Pros and cons of stacks and/or queues using an array or a linked list. Okay. So it's the same story, but in a different way told, right? Like, when do you want a linked list stack? When do you want a queue stack? What is the pro and con? So pretty much linked lists, in the case of a stack or queue, have pretty much all pros when it comes to a linked list version of them, and like barely any cons, if any. Whereas the arrays have the con of the resizing, whether you are doing a stack or a queue. But I guess it's efficient if you have it always full, because you don't have to store data with the pointer. Like, you don't have to store that. The pointer takes space in memory. So technically, the link, if you have data, let's say you have 5 pieces of data, and those 5 pieces of data you want to store, and they're always going to be 5. You got to decide between an array and a linked list, and you're never going to change them. The linked list will take more space, because not only are you storing the 5 pieces of data, you're storing also 5 pointers so that you can point them to each data, right? Of those 5, one of them is going to be null at the end, but the other 4 will be linking them together. So if your data is integers and they take 4 bytes, your pointers are going to also probably be 4 bytes long. And so it takes twice the amount of space as a linked list, right? Now, that value becomes insignificant when you start dealing with not just like integers, but like objects. So like, let's say you have an object that contains a student record and it's like 1 megabyte per student record or something. With a linked list, it's going to be insignificant that you have to add another 4 bytes to a megabyte. It's going to be like such a small percentage increase of space that it won't matter much. But, it's still a little bit of extra space, right? The array one doesn't require that. And again, it has that quick access time. So in general, space is something to think about. But overall, when you're looking at a stack or queue, linked list wins every day, aside from that space issue that I mentioned. Obviously, though, within an array implementation of a queue, we saw the right way of doing it and the bad way of doing it, right? So you want to make a circular array or a circular queue when you're implementing it with an array. Otherwise, you're just being inefficient for no purpose at all, other than not knowing a better way of solving it. So anyways, let's go back to the other question about the linked list now that I left it for a while. So the question was, can we make a node that just has all pointers and not data? Like, not actual physical data? And the answer is, yeah, you can, instead of making this data component be actually a data component that is like an actual object there, you just make that a pointer to the actual data somewhere else. So then technically speaking, your node is just made up of pointers. We have a pointer to data, and we have a pointer to the next node. Or if it has a previous pointer, it also has a previous pointer. So it's all pointers technically. And the data itself is dynamically allocated. Why do you do this? I'm not sure. but I'm just saying, in theory, you could have a node with just pointers. So slightly of a trick question, but it does kind of help you think about it in a different way. Of course, remember your FIFO and LIFO acronyms: first in, first out, last in, first out, and what they are for, like stack or queue. But yeah, those are really the only ones that I kind of see here that the type of question that you get. Applications of stacks and queues, understand examples of them. We talked about a lot. Queues, of course, anytime you're dealing with a line, waiting in a queue is like the standard way of waiting on something. But if you're trying to organize in a computer like a process to run, you want to be fair and make things that have been waiting the longest run first. As for a stack, you know, we gave the example of the plate dishes in the buffet. You can also think of like when you're stacking things in a store up into a shelf, so you only have access to the front. Whereas like with the dairy, they have fridges from behind, so they can actually put the milk from behind. So that's a queue actually. That one's more of a queue. Other usages of a stack being your computer, your call stack. That's a stack too. That's the most important one, I guess. So there's tons of examples, but just be aware of some of them in case you get asked like what a stack or queue are good for. But yeah, that's all I have. Anything else? Any other questions that you can think of asking? Any other topics? We have an hour. We have 45 minutes of anything. Now is your chance. Got my dog. So I can't sit straight. She's sitting on the chair behind me, so. So no questions, nothing? I mean, I can try to think of something, but I just don't know. What are the programming questions like related to linked list? Let's see. Where did that go? So the questions will ask you things like, here's some code. Finish the implementation of a function. So for example, they might give you a linked list that's missing like the insert function or the delete function or the search functions of some sort. Or they might ask you to convert a singly linked list into a doubly linked list. And they give you the code for the singly linked list. They might ask you to add a head pointer. Now they, you know, for example, for the insert one, right? They might like, you might, whoa, writing an insert function is like a lot harder, or not harder, but a lot more time consuming than like writing a delete function. So because of that, the function, it will not ask you to write like all cases. Remember those 4 cases when you have an insert, right? So when you're inserting into a linked list, you have 4 cases. You have one case, which is the list is empty. And then you have 3 cases. This is empty. And this is not empty. So for the not empty, we have a case where we insert at the beginning, at the end, and then somewhere in the middle. And by middle, I mean there must be at least one node before you and at least one node after where you're inserting. And so they'll ask you to do one of the cases. So for example, they might say, write the insert function that will insert at the end of the function. So if you remember when we actually wrote the first linked list, I wrote the function separately, and then I wrote the big function that combined them all. So you can definitely take a look at that to refresh how to write each of these individually. But here, let's just do the end one really fast. So, let's say that we're inserting an item. So, let's say it's an integer data. So what you gotta do is you gotta get the head value. So make a new pointer. We'll say the node is called just node. We'll make it cur equal to the head. Let's just say there's no tail pointer here. Okay. If there's no tail pointer, we have to work through the entire list. So you can say while cur is not equal. Actually, I'm gonna do this in a different way. We can say if cur is not equal to null. I'll take a safety check to make sure that it's not empty. Not empty. So you can actually go on and proceed. Again, this is only asking to insert at the ending of the list, but like, what if the list is empty? Like, play it safe. I don't know if I would assume they're not asking you to do that check, but just play it safe. So if the list is not empty, then that means that there is at least one node in the list. So then your while loop can be something like this. And then just do cur gets cur next. Once this loop finishes, that means that cur next is the end. So that means that cur is the last node in the list. So then you can just go ahead and create it. So you can just say cur next gets new, and then just call the constructor to build it, and then pass in your data, node, and you're done. Okay. Now this is option 1 if there's no tail pointer. If there's a tail pointer, then this is like 50 times easier, because all you gotta do is say tail next gets your new node, and then after that go ahead and actually set tail to get tail next, just to make sure the tail now points to the new ending of the list. So yeah, so option 1 or option B, really. Again, for option B, the same situation arises. I would play safe and write a code that says if tail is not equal to null. Okay? Again, you don't want them to call this function when the list is empty and crash, right? So add that extra check. So yeah. Now, question, if it's not too much to ask, could you go over the makefile part for assignment 10? Makefile part. Ooh, that sounds scary. I can try. I'm downloading assignment 10 right now so that I can see it. So makefiles are just scripts to compile your code. I don't see a makefile included. Do you have to make one? Oh, I see. Okay. So I mostly use makefiles for LaTeX, but it's kind of the same approach. The makefile is just a list of commands to compile your code and any arguments that you need to pass in to compile it, such as like linking for libraries and whatnot. So I would agree with what someone else said, which is to just basically look at an older makefile and use that as an example so that you kind of have an idea of where to start. But out here, I'm just finding a makefile so that I can at least go over the basics of it. So here, I found a makefile from assignment 8. Let me just extract it. Yeah, okay. It's good. I'm glad this makefile is simple so I can go over it. All right. So, all right. I'm gonna copy into the VM just to make it bigger because this is really tiny and painful because it's white and like the dark background works better. Yeah, this looks nicer. Okay. So this is actually assignment 6, not 8. Or actually it's assignment 8, but they put the one from 6. Maybe that's weird. Maybe they made a typo on the name. Is this the right file? That's weird. Why do they Okay, well either way, doesn't matter where it's from. Let's just look at it really fast, okay? So this is bash. It's like a bash script in a way. The first thing you should know is when you want to write a comment in a makefile, you can use the pound symbol. So like Python in a way. So if in this case, this is being ignored by the script, okay? Similarly, this line of code and this line of code is ignored. So yeah, you can put as many comments as you want. You could say like, this is a comment, okay? The next part of this is you have different commands. So you have like a clean command and then you have your all command and whatnot. So when you run a makefile, all you're supposed to have to type is the word make, and then this in the same directory as where the code is and the makefile is, and it should automatically compile the code for you. However, sometimes you want to remove temporary files before you compile, or you just want to remove them in general after you finish compiling. So clean will do that. So if you type in make clean, so like if I'm in a terminal, so like this is my terminal right here, and I type in make, that should automatically build this. If I type in make clean, then that will clean the directory by running whatever this is. In this case, it's removing all the object files. So like all the temporary files that are used for compiling. What I like to do is I like to actually do something like this. Make clean make, because that's going to clean up the temporary files and then recompile. So like in LaTeX, I actually have a third version where I have like a make clean PDF. What this does is it cleans the directory, compiles my LaTeX code, and then actually removes all the temporary files already, but leaves the PDF behind. And that way I can use a Git repository and not put garbage in there as well. So yeah, that's just temporary. If you don't know LaTeX, you will someday. It's just programming for. It's like imagine Microsoft Word, but if you use programming instead of Microsoft Word. Okay. So anyways, how does this work? So okay, I'll just kind of work my way down. So this is the compiler that you want to use. So you just leave this by default. Like literally when you're starting your own makefile, copy and paste this. And then when you want to change, you want to leave this as a default compiler. These flags, unless I don't know if the assignment tells you to add or remove flags, but these are the flags that are being put when you compile. So like if you were doing this by hand, this would be the equivalent of you saying G++ -w extra -pedantic, which are all these error catching things, and then the C++ compiler format. That's the equivalent of you running, what is -g? I don't remember. That, okay? So this is just listing all the arguments. If you remove this, for example, that would be the equivalent of you removing this from your compiling like argument list, okay? The next thing is you have dependencies. So you might be doing like a multi-file compilation, which is probably why you're using a makefile, not just a single line of code to compile. You can list all the files that you're using right here, just like this, space separated. So if you had a file called potato.h, you would put it in there and it'll automatically include it. Now be careful about doing this, because if you're doing this, then you might not actually have to do the word include when you're compiling. Otherwise you include it twice. Whole different story there. But I'm just saying, makefile wise, what you do there. Okay, this is your main file, so just leave that be as is, and then also leave these be as are, so that the things don't break. So leave all this the same. All you gotta really change is this. Yeah, it's like variables. Yeah, they are. Bash scripting, you put a $sign to make them variables. So that's why you see $signs here, I think. So yeah, this is like storing in the word object is storing this, and the word in variable department is storing this, and so on. So yeah. In dependencies, you're only just putting the other files that you have. If your entire code is in one file, then you don't need to put anything here. Ignore this. It's trying to think this is Python. That's why it's underlined and everything. But yeah. So like these, you could have no flags for this, actually. Although you might want to leave at least this one in here so that it uses C++11. But you could remove these checks. Although, maybe these checks are done in the code grade, so maybe leave them so you can see the warnings locally. But yes, if you don't have any dependencies, you can remove those for sure. In fact, if I go to Stack Overflow, like the most basic makefile, C++. Let's see what that one looks like. How to make a simple makefile. See if I find an even. Oh, see, this is like 10 times more complex than the one we have. Yeah, no, I'm not putting that one in. I was expecting like the shortest, simplest makefile possible, and then they just go and put in like a massive one. Yeah, this one's slightly simpler. Okay. Here's one. Those crates require since coder has it. Yeah, I suspected that. Here's a slightly simpler one. So you have G++ compiler. You have an older version of the compiler, I guess, 2006, I guess. Whatever this 0x, I forgot what this means. You have only one check. In this case, there's two objects that are joining here. And then they have some HPPP. No, because this is using this variable stuff. I forgot what it even means. Yeah, use the older ones. That is going to make your life easier. CC's flags, all file name, file complete, and then clean. Yeah, that's probably the best way to do it. You don't have to make this overcomplicated. Just keep it simple. But here, I'll post this Stack Overflow one because they have more examples there, so you can see if there's any that you can test locally. So, but yes, cool. Any other questions? I guess I'll let you know when the test is, if you don't know already. The test is scheduled for Wednesday, December 8th. 6 to 8 p.m. So that's kind of trippy because it's outside of our normal time. Well, not outside, but partially outside because class normally starts at 5:30, but it just starts at 6. And it does run until 8 p.m. Okay, and this is not something that I set up. This is something that UNLV sets up so that exam schedules don't conflict between different classes. So we just have to follow what they say. So make sure you're here. Well, by here I mean online. Okay. My only concern is about linked lists since it's new. Yeah, linked lists can be a little bit intimidating because of all the pointer stuff and getting everything working right. I think as long as you have the references that I wrote and then you practice it yourself, then I think you'll be okay. Worst case scenario, just get everything else right, just in case. That's my suggestion with linked lists. But it's all about perspective. When you get to 302, you'll be like, linked list. Those were the nice times, the good times. Now we have ABL trees and graphs. When you're doing a graph, it's like a linked list, but with like unlimited amount of pointers going out of it. So at that point, a linked list is like a simple graph. In fact, a linked list is what is known as a unary tree, because it's a tree with only one branch, right? In 302, you're going to learn about binary trees, which are like linked lists that have a left and right pointer. And then from there, at the end of the semester, you're going to learn about graphs, which are just like free for all, could have pointers everywhere, etc., etc., and so on. That looks like a person, doesn't it? Yeah, it's like a little dude, like body lifter or something. Okay, but yeah, no lockdown browser. The test is open notes, open book if you have the DS Malloc book. So yeah, and you do get the 2 hours because it's a 2-hour time gap. So like that's also why it's a little longer too. 33 questions, I think we said, because you do have 2 hours. So it should be simple test, I hope. But either way, reminder, today is the last day to submit the extra credit. $218 will be fine if it's in the regular semester. It's only the summer where it gets really intense. Now we got the winter break too. That's nice. Also, don't forget to send me your names if you do redeem. Will we just email you our username for the extra credit? Yes, so email me your Twitch username, your Canvas real name, and CS202 associated. Just makes it easier to find you between the 2 classes. Email me or Discord me, either or. Yep. Winter break ends in January. I think the first day is like the 20 something. Maybe 2020, the 20th maybe? 21st because of MLK Day. Usually that first day is there's no class because Martin Luther King Day, right? Did I get that dates wrong? Oh yeah, I was looking at December. That's why. Okay, so it's actually the 17th, the 18th. So January 18th is a Tuesday. That's the first day of class because the Monday is MLK Day. So yes, the 18th, and then by the way, you can expect your final grades to come in on Tuesday, the 14th. Well, on my UNLV, because my goal is to submit them on the 13th, which is Monday, so Monday night. And then they'll probably populate on my UNLV at some point Tuesday afternoon. However, before that, you will get to see them on campus as soon as they get graded. Basically, I gotta wait until all the grades are in, then I do the final calculations, and then I basically go and submit them to my UNLV. It's a very gruesome process because I gotta have a spreadsheet from Canvas grade and my UNLV, and I'm scared that I'm gonna put the wrong grade for someone. I've never done that so far. Fingers crossed, knock on wood and everything. But I've known of people who have done it, and it sucks because then you gotta like do a form and get it signed by like 10 people, and the student has to be involved, and it takes like a month to do. And it's not bad if it's like, oh, A or B or whatever. It's bad when you like fail a class instead of not failing a class, because that like screws up like enrollment for the student, and no, it's a nightmare. So I always like literally like triple check, like actually triple check, like 1, 2, 3. And like so far I've never messed it up for anybody. But still, you should check it yourselves in case I do mess it up. And if I do mess it up and it's not in your favor, then let me know. If it's in your favor, then I guess just don't say anything. You got lucky, basically. But like I said, at least I've never known to have messed it up. Can the extra credit only fill in for assignments? No, it just goes into the homework points category. So potentially, if you get over 100 in the homework point category, it would help the other categories. But it is weighted, so homework is only worth like 50% of the grade. So you need a lot of extra points to affect the other scales a little bit. But basically, yeah, whatever your grid on Canvas is like the actual scale system. Like I set that up correctly so that you can, if you have over 100 because of the homework points, then you do really have over 100. I mean, I can only give you an A. There's not even an A plus in my UNLV, but yeah, you have the personal satisfaction of knowing that you got over 100. I'm petting my puppy. Not so puppy anymore, but she's my puppy. Well, like I said, I will just hang around for maybe another 5-10 minutes, unless more questions come up. Then let you all go. So again, no class on Tuesday or Wednesday, but do use the time wisely to practice for the test, finish any and all remaining assignments, and if you're submitting extra credit notes, submit them by the end of the day today. And if you have any questions or anything like that, contact us as soon as possible. That way, it's going to be pretty hectic next week. So don't wait if there's something that comes up, like as soon as possible. If during the test you have a problem with the test, you just keep going. You can send out a message to the TAs or myself, but you just, we'll take that into account. So like, remember, if there's a question on a topic that you think we didn't cover, like if you're not sure, then, when the test finishes and, remember the question and then check it. If that's the case, then, 3 points. But we have to confirm that. So you have to let us know. I really can't think of anything else to say at this point. I think you all just gotta go prepare for the test and ace the test and then have a good winter break, basically. 4 more hours. That's a long stream. What games? I bought the GTA trilogy, but then I couldn't play it for like a week before because Rockstar like ruined the launch. Other than that, I haven't really played anything. No, I played Call of Duty Warzone, I think. I can't remember if I played it. I want to say I have, but I don't remember if I did. I bought a bunch of games that I didn't play. Like I bought Deathloop, I bought Age of Empires 4, I bought a bunch of virtual reality games. I haven't played any of them. I think I played Age of Empires 4 one time. And I played Deathloop 2 times. I bought Battlefield. I played that once. I haven't played it since. But I do like that game actually. I just been busy. And I bought Call of Duty Vanguard, which I also haven't really played. So, but the winter break is coming, so I'll get to play some stuff then. I also played the Halo Infinite. Yeah, I did play the Halo Infinite. I did actually play one of those games. I don't like that game though. It's not fun. I'm not an Xbox person, so I never got into those games when I was a kid. And so, to me, it feels too arcadey. And other people I know are like having so much fun, and I'm just like, it's just kind of repetitive. It feels very like, it feels like what video games were like 20 years ago. Like, you know, it's like we advanced since then. But that game is literally the same game. So I don't have the nostalgia to, you know, versus like playing the Grand Theft Auto games, which I do have nostalgia for. So like that's different. I actually own Destiny 2, but I never played it. I got it with a GPU that I bought. VR is fun though. I want to do VR, more VR. Not just playing it, but some development stuff too. That's why I did the AR app. I also have a HoloLens that I bought that I want to do some cool stuff with. I just don't have the times. But the winter break is here, so I'll actually get to do a lot of that stuff now. It's good exercise too. Beat Saber's a fun game. But I like the ping pong one, tabletop tennis, and I like the shooters. The shooters are fun. Like it feels very like surreal. You should just do more exercise. Then you get more energy. I think I'm pretty healthy now. Over the last few months, I've gotten pretty healthy. If you go and look at a stream from a year ago, I look thinner now. It's kind of weird to see that progress. Should make a progress video or something. The UNO sure. I'm trying to show the engineering part, but I have to like I can't stand straighter to stand up. Too many to name. But I've been to lots of places. And I do plan on going to some places, but don't want to say anything because I don't want to jinx it if I don't get to go. But tons of places. I love to travel. Travel is very fun. I did want to go there, actually. I've been there once when I was a kid. Really young, though, so I don't remember a lot. But, yeah, I actually wanted to go for the Olympics as well. Well, I don't know if you want to go to the Olympics, but I assume that's kind of what you wanted to go for, like that era. But, yes, they actually haven't reopened it either, so you can't even go if you wanted to. I don't know what that is. I don't watch TV really. I watch some movies, and I still have a backlog on those too. Netflix. Yeah, I know. I don't really watch Netflix. I only saw the Squid Game. That was the only series I've seen this year. I actually was thinking of doing an assignment on that just for the fun of it, but I didn't have any assignments left for this class because that would have been a cool assignment to do on that game. Like I was thinking how to implement that. Like what would be cool for that? Like you could code one of the games. You could even do like a queue or a stack for that. You know, like there would be tons of cool things that you can kind of create. You have to just go creative with it. For things as basic as classes, then you can just make the class be a contestant and give them some features. You want to make that, or if you want to do like uh, a linked list that it's like when they're playing tug of war, that's your linked list right there. But so there's a lot of things you could do, but really those kind of things are more creative in 302. You can come up with more creative assignments in that. This class you can't do that much. I mean, you can do some creative stuff, but you can't do so much because you're limited by none. Half of the assignments you don't use pointers yet, so pointers are kind of important to do creative things. But either way, it wasn't my assignments that I had to do. I finished those, so yeah. Is that the game where you cut thing from the thing? But yeah, like deallocating a player could be deleting them. Yeah, eliminating them. There's a lot of fun assignments that I've done in the past and entertained myself doing that. I mean, it's cool to have, when you get to code those things, create them. But yeah, you'll get to see those when you get to 302. You get way more cooler assignments. There's just a lot of things you can do in 302 with assignments. Like I have in my 302, I do the assignments. I don't have to share them with other like instructors. So I do them all. And like I have pretty much every single assignment is themed on a movie of some sort. I have James Bond, I have Edge of Tomorrow, CSGO, oh yeah, you had an Inception assignment for this class, for the linked list assignment. That was Inception. There were different layers of that. That was the final project some years ago. There's a lot of fun things you can do for assignments. But I mean, like, who else is going to pay you to code that kind of fun stuff? So it's kind of neat. It's a nice part of it to do that stuff. It does get tiresome after a while, but it is definitely fun to do that once in a while. It's a good way to refresh before the semester starts and you're making an assignment. It's a good way to refresh the material too, as you're coding it. All right, so we have reached the end of our time for the review, and I did wish that you had a little bit more questions, but it's okay. If you do have any questions in the next couple of days, my suggestion is to post a message on Discord and we can help you out. On behalf of Padme and myself, we thank you all for watching the lectures. And, this is the beginning of your CS career. You've only really taken CS 135 and CS 202, so you're if you're doing CS, then this is just the beginning. But it is important. This class is important because there's a foundation aspect to it that you need for future classes, and that's the foundation of programming. And so when you came from 135, you knew coding, but very basic level. The projects you did were probably pretty small. This class expanded the scope of programs that you were making into like larger things, more realistic looking things. Obviously, you're not at the point where you're coding thousands of lines, but you could. You're just not there yet. So that kind of expanded the scope of that. But you also started to look at programming and more of just like how to do A to B, how to do A to B elegantly, how to do it the right way, how to take advantage of more than just the basic tools to really try to achieve something that's greater, right? And so when you move on to the higher level classes, It's no longer about learning how to program. It's going to be more about things like linked lists and stacks and queues and the recursion and these concepts. But the foundations will need to be there because you will need to program in those courses, at least in some of them. And so this is a class that really kind of prepares you for that. And I hope that I did a good enough job that you have a foundations of programming enough to be able to go into those classes and have a good starting point, that you're not behind and you're like, oh snap, I really didn't code that much linked list in this class, or I didn't really code this much of this, and now I got to code something similar, but I don't have that practice, right? So ultimately, the goal of this class is to prepare you for those classes, but also to give you a strong foundation of programming so that you can learn future languages on your own very easily. So like if you go and learn Python, or you go and learn C# or Java in another class, that you know what an if statement is, you know what a loop is, you know what a class is, you know the concepts of object-oriented programming, you know how inheritance works, you know all these things. So now all you gotta know is, okay, I know how to do a for loop, like I've done it for a year or more now. How you do a for loop in Java. And so you see that syntax, you see the syntax in C++ that you know, and you see the similarities, and you're like, oh, okay, this is what I do, or how I do this in Python or somewhere else. So the foundations are there, and so picking up in the language is very easy. It's just a matter of learning the syntax differences. Like you don't use semicolons, you use tabs, or you do this, you do that, but the foundations are there. And so that's really the heart of this class. It's to be good at C++, but also to have the foundations so that you can branch out and learn more on your own. And that's something that I think that you should do. You should enjoy your winter break first and foremost, but you should also try to start growing as a programmer and do projects on your own, do your own GitHub, code projects for friends, code projects for yourself, go code a pre-order bot. I did that last winter break because the hype with the GPUs, and it worked for a while until I stopped supporting it, and then it doesn't work anymore. But it was a fun project, and those are the things that motivate you to actually do projects on your own and actually complete them, or at least do enough that you have a good portfolio piece as well. And so that should be you right now. You should be thinking about those things. You should be looking at the world and seeing, how can I turn this into code? How can I do this and that? How can I use my programming skills to make my life easier? And so I hope that you do a little bit of that out there. And I hope that when you do that, some of the stuff that you learn in this class remains there. And so wherever, I don't know if you'll take me for a future class. That's not the point. But I do hope that wherever you go, that what you took in this class helps you in the real world and helps you in your future classes, and that it made a difference. And ultimately, nobody's perfect. I don't think this class is by any means perfect. And I don't think that the way that we taught the class online is by any means perfect either. But I think given the situation with the world, and given the situation of you being here and taking this class, I think that hopefully that I did you justice enough that you learned the content one way or another. And so, I hope that you do good on that, and I hope that that it all goes well, and you're more than welcome to stay on Discord and hang out with the other people there. And if 4 years from now you're working at Intel or somewhere really cool, share that with us, because we want to know. We want to know where you all end up. Whether it's good or bad, I guess. So I'm hoping that I had a positive impact. That 20 years from now you remember this as a positive experience. Or a neutral experience, but at least not as a negative experience. That's my only hope, But then again, you can't please everybody, so I hope that the majority of you have a positive experience. That's a more truer statement, I think. Okay, so that's cool too. If you pull a heist, hack like 100 million from the Russians, then you can go back and donate to UNLV some money too. Just don't get caught, I guess. All right, but. Yeah, awesome. Okay then. So it's not goodbye. I'm still going to be around on Discord. I'm not going anywhere. And I'm not going anywhere at least within the next, 2 or 3 years at least. I'll be at least at UNLV. I don't know if in the future I'll stay there, what will happen. But at least for now, I'll be there. So you can stop by my office if we ever go back to in person. But if not, I'll be on Discord probably forever unless it dies like Xfire did at some point years ago, or MSN Messenger or something. And so... whatever it is, or MySpace. So, but yeah, I'll be around on Discord. So, best of luck on the exam. Let me know if anyone has any questions. And if not, I'll see you around. Okay? Thank you all for being a great class. I'm very happy that you all talked and I was not just staring into the void. So I do actually really appreciate that, and I think that, you know, keep doing that. Like, I'm being honest here when I tell you that I actually do appreciate the questions people ask, and I do appreciate the comments. I do like that. That interactivity is what keeps somebody awake when you're trying to talk and teach. So I'm very grateful for that. Okay, so good luck in not just this final, but all your finals, and enjoy your winter break. If we don't talk one-to-one again, okay? But I'm on Discord, so you can find me. All right. Good luck, and thanks for watching. All right. I'll see you around sometime. Yep. Come on, Pam. Say bye. All right. We'll see you around.